How does unified IT service management bring asset visibility and application dependency mapping together to reduce outages, risk, and manual effort? Hello and welcome to the second in a series of Freshworks videos on unified IT service management. This video dives deeper into IT asset management and IT operations management, and most importantly, how these capabilities will help your organization to improve in IT service delivery and support. We'll also cover the importance of artificial intelligence to ITAM and ITOM, and these capabilities to AI use in service management, because AI outcomes will often depend on unified data and consistent workflows. Let's start with a quick refresher on what some of these terms mean. So, as a reminder from the first video, unified IT service management is the natural convergence of IT service management, enterprise service management, IT operations management, and IT asset management to deliver end-to-end visibility and faster issue resolution. ITAM is the process of systematically tracking, managing, and optimizing an organization's IT assets throughout their life cycle. It helps ensure that every asset is accounted for, properly maintained, and aligned with the organization's strategic goals. And ITOM helps your tech systems run reliably by monitoring, managing, and fine-tuning everything from hardware and software to networks and data centers. It's no longer just about keeping things up and running, it's about staying ahead, avoiding downtime, and growing your business. Let's do a deeper dive into ITAM and the term asset visibility. This is the ability to know at any point in time what IT assets you have, where they are, who is using or is responsible for them, what condition they're in, how they're being used, and what they cost and what obligations exist. Importantly, you need to trust this information enough to make decisions based on it. Without asset visibility, there might be slow incident resolution because support teams lack visibility into affected devices. ITSM decisions might be guesses rather than data-informed. Costs creep and security and compliance risks grow, and importantly, automation and AI might not work reliably. Whereas with strong asset visibility, incidents are resolved faster, changes carry less risk, spend is optimized, and end-user engagements with IT are better experiences. Ultimately, this asset visibility reduces outages, risk, and manual effort. A practical example of these differences is an IT service desk experiencing repeated VPN issues. With asset visibility, all affected end users are seen as using a single laptop model nearing end of life. These laptops can be replaced proactively. Without asset visibility, IT service desk agents might reinstall the VPN client multiple times, but still fail to resolve the issue for end users. It's the same end user symptom, but the IT support outcome is completely different. While there's much talk in the ITSM space about the power of AI to improve IT service delivery and support, you shouldn't overlook the opportunities to leverage AI capabilities to improve asset visibility. The elevator pitch here is that AI improves asset visibility by turning what might be scattered imperfect data into a continuously updated, trustworthy picture of your IT asset estate, and with far less manual effort. Examples of how AI assists with asset visibility include smarter asset discovery that correlates data from multiple sources, including network scans, endpoint management tools, cloud APIs, and procurement data. Using probabilistic matching, fuzzy logic, and behavioral and relational clues to understand if different records relate to the same asset. Inferring asset lifecycle states even when data is incomplete, and dramatically improving visibility into what software is actually used, not just installed or purchased. Detecting devices acting outside baseline behavior with abnormal communication patterns or consuming unexpected resources. Offering natural language access to asset visibility. For example, you could ask, which assets are nearing end of support this quarter? Or which laptops generate the most incidents, rather than needing to create specific, potentially technical reports. Let's now do a deeper dive into ITOM and the term application dependency mapping. Application dependency mapping is the process of identifying, visualizing, and maintaining the relationships between an application and everything it depends on to function. This includes infrastructure, other applications, services, data paths, and network components. In simple terms, application dependency mapping answers the question, if this application stops working or needs changes, what else is involved and what else breaks? Without application dependency mapping, incident management is inefficient. For example, separate incidents might be open for web server slowness, database alerts, and network latency complaints, with different IT support personnel troubleshooting in parallel. Incident prioritization might be wrong. For example, a non-critical server goes down, but it actually plays a role in a critical business service, such as the corporate payroll. Unexpected outages can occur due to unknown dependencies during change management. Related incidents might be closed individually with no visible pattern to identify the root cause. Whereas with strong application dependency mapping, incidents are resolved faster. For example, ITOM detects latency off the cache service. Application dependency mapping shows all the affected applications, and ITSM opens one incident automatically linked to the impacted services. The business impact of IT incidents is known. For example, application dependency mapping shows the server dependency for the corporate payroll application I just mentioned. Dependency information will likely increase risk scores and enable more informed change decisions. Business needs are met and end-user engagements with IT are better experiences. Ultimately, the use of application dependency mapping also reduces outages, risk, and manual effort. A good practical example of the benefits of application dependency mapping is when end users report that an application is down. Without application dependency mapping, the IT service desk opens multiple incidents. The app team restarts the application. The database team might check database health. The network team could be pulled in just in case. And the root cause is found 90 minutes later, a shared authentication service failed. Whereas with application dependency mapping, monitoring detects the auth service failure. Application dependency mapping shows all the affected applications. The IT service desk opens one incident, which is auto-prioritized based on business impact. The auth service team is engaged immediately, and service is restored in 15 minutes. It saves manual effort, speeds up resolution times, and reduces the business impact. Plus, it's a better experience for everyone involved. This is a classic example of how application dependency mapping changes outcomes. While there's much talk in the ITSM space about the power of AI to improve IT service delivery and support, you shouldn't overlook the opportunities to leverage AI capabilities to enhance application dependency mapping. The elevator pitch here is that AI improves application dependency mapping by turning it from manual, potentially incomplete diagrams into a living, self-updating understanding of how your organization's applications actually behave at runtime. Examples of how AI assists with application dependency mapping include real dependencies are detected automatically using runtime behavior. Noise and false connections are filtered. For example, not every connection matters. Dependency maps are kept current with AI learning baselines, spotting dependency changes, and updating maps automatically. And because AI understands importance, not just existence, ITSM personnel can prioritize incidents and changes based on true impact. While much of what I've said so far about asset visibility and application dependency mapping is focused on faster incident resolution, speed is an operational perspective. What's more important are better business outcomes and end-user experiences, with poor experiences often manifested in what the IT industry has termed employee friction. A good example is a slow-running laptop. Improved asset visibility indicates that the laptop is over 4 years old and out of warranty. The end user also has high performance needs, and ITSM data shows that this is yet another related issue. ITOM data shows that the CPU is running at 95% for long periods. There are memory spikes when running design apps, and the laptop is frequently overheating. With this connected view, the laptop will be replaced. However, without it, the limited or poor asset and event data causes employee friction, and IT support is likely to apply yet another unsuccessful fix that doesn't address the underlying issues. Another good example is an internal forecasting and planning portal used during month-end and quarterly planning. Improved asset visibility shows that systems supporting it are old and nearing end of support. There are usage spikes at predictable times, and service data shows repeat complaints that the updates are slow or fail when the teams are working at the same time. Operations data shows the platform runs close to its limits for long periods during these peaks, and performance drops as more teams load and refresh plans. With this connected view, capacity can be added or the platform can be refreshed before the next planning cycle. However, without it, limited visibility into assets and dependencies causes employee friction, and IT support is likely to apply yet another short-term fix that doesn't address the underlying issues. Asset visibility and application dependency mapping, in particular when used with ITSM as part of a unified IT service management approach, help reduce outages, risk and manual effort, facilitating increased productivity, improving insight and decision making, elevating uptime, speeding up resolution, and most importantly, delivering better experiences and business outcomes. In the third video in this Unified IT Service Management series, we'll cover Enterprise Service Management. To be alerted to this and for more ITSM content, please subscribe to the Freshservice YouTube channel. Hopefully we'll see you again soon.